Yeah, I'm getting there. The LED lights up. It's hard to see on film, but it lights up when we close the circuit. So if we have a conductive solution, if we have a solution which conducts electricity, then when we stick the ends here into the solution, it ought to light up. Whoops. And we can't see that on film, but can you guys see it? Brianna can be my guarantor here. Calcium chloride solution. That puppy is lit. So you can see that the calcium chloride solution does in fact conduct electricity. You're recording this in your data table, I assume? That would be clever. It would, wouldn't it? Okay, so let's continue solution testing, and I'm going to rinse off my electrodes. So we say that calcium chloride is conductive. So we'll rinse off the probes with distilled water. Why don't we use tap water? It's got ions in it, potentially. So now we'll go ahead and we'll go to the sucrose. And I'm going to stick the ends of the probes in the sucrose. Nothing. Not lit. Into the sucrose. Still not lit. Sucrose is non... Did that just light? No. Okay. It looked for a minute on film like it lit, but it did not. Okay, so we've got sucrose non-conductive. Let's rinse the ends of the probes again, and I'm just going to make a mess here. There. Okay, and we have sodium chloride here. Okay, and there is our light not lit into the sodium chloride. And we've got pretty clear conduction. That puppy lights up nicely. I realize that the video is frozen, but it definitely lights in the sodium chloride. Okay, so far we've got two that are conductive, one that is not. We'll go to citric acid. Let's rinse our probes. Okay, not lit. And probes into the citric acid. I think my wires are touching. Some paper towel here. A big mess that I'm making. Let's wipe off my probes. Okay, so we get non-conductive for citric acid. Oh, it gets, every now and then you get a little weak glimmer of conduction. Very weak. But overall, we would say citric acid is non-conductive. Okay. We're going to do these out of order because phenyl salicylate. Was phenyl salicylate soluble in water? No. And what we have here, when I told my lovely assistant to make a solution of phenyl salicylate, what we really get is a big mess. There's our phenyl salicylate. So we'll save the mess for last. Then here's our potassium iodide. So we have potassium iodide solution, we have our probes, and we get a clear light up with potassium iodide, as long as I get both probes into the solution. Very, very clear conduction there. That's one heck of a conductor. Wow. Like we're electroplating our probes. It's that good a conductor. Not electroplating, but we're reacting off the copper. Okay, so potassium iodide conductive. And let's do the phenyl salicylate. Now, is this actually a solution, the phenyl salicylate? No, it's not soluble. It's not even a solution. So, you know, testing for conductivity is kind of silly, but we do it anyway, and hey, no surprise there. Nada. Many years ago, in another lifetime, I worked for the Division of Natural Resources, Department of Wildlife, and we used to go out doing what's called Electro night fishing. How many of you have ever encountered an electrical field, like grabbed an electric fence, brushed up against a cord that had all the insulation off of it, something along those lines? Gives you a nice little zzz, and when you get that nice little zzz, what happens to your muscles? They lock, they contract. If of course you get that current across your heart muscle contracts strongly, locks up, and you die. That's how current kills. So electro night fishing is this fabulous way of sampling fish populations. You have a big boat. Off the front of that boat is a long boom. It's basically just an aluminum pole. And hanging out on the end of that boom is a figure 8 made of thin aluminum rod. Dangling down from that figure 8 that hangs out on the end of this pole out over the water are a bunch of wires with big chunks of aluminum on the ends of them. And those wires have a bunch of like big giant alligator clips, and you clip them onto the figure 8. And on the boat there's some lucky soul, usually it was me, standing there with their foot on a pedal, and as long as your foot is on the pedal, current is flowing out that rod, through that figure 8, down those wires, into those chunks of aluminum, and out into the water. And you're creating this lovely area of electrical field all around the boat. And when fish swim into that electrical field, guess what happens to their muscles? They lock up. And they freeze, and they float to the surface, and you know that same poor sucker who's standing on deck with their foot on the pedal has a long handled net. And you scoop up the fish, you dump them in a well on the boat, and while they're immobilized, you typically weigh them, get a length, get a scale sample, and depending on the survey you're doing, sometimes you tag them for re-release. So every time that you go out electro night fishing, and it was the biologist's job. I was not the biologist. I was like the little low-wage $8 an hour natural resource worker. I just had a bachelor's degree in biology. I was, you know, bottom of the totem pole. I got to clean up all the dead fish guts at the end of survey work. The biologist would go out in the lake and would do it's a clarity test. It's a Secchi disc reading. And you look at how far down you can see a patterned disc in the water. And what that tells you is how many particulates are floating around in that water. Because lake water's full of everything, you know, goose poop, fish pee, runoff from farm fields, you know, everything. Anything you can imagine is in that lake. Based on the Secchi disc reading, they would tell us how many electrodes to put on the boat. So how does this relate to this lab, Moser? Come on, seriously, we're getting old. Pure water, would it surprise you to know, is not conductive at all. If you want to go out and swim in a lake of distilled water in a lightning storm and shake your fist at the sky, go for it. Distilled water is not conductive. However, particular solutions of water tend to be conductive. Lakes and rivers and puddles are great conductors of electricity because no lake on the planet is pure water. They got all kinds of stuff in them. So based on the results that we've seen here, you might begin to start to make some generalizations about what kind of solutions are conductive. We've got enough time to talk about some of the rest of the lab. Good. I'll keep talking on tape. What the heck? Okay, so looking at the lab packet, I can't pause this video. It doesn't work that way. You can't pause this. Can I steal a glance? Thank you. Looking at the lab packet, when it asks you to group them into two groups. Group your white substances into two. They were all white crystals. Group them into two groups based on their properties. So what properties are you looking at? Conductivity is one of those properties. Solubility in water or ethanol. And what's the other property you tested? Melting point. Now, you don't have specific melting points. You can't say that something melted at 125 degrees Fahrenheit or 400 Celsius. What you can say is, lower melting points. So you have things that you're able to melt with a candle flame. And then there were things that you couldn't melt with a candle flame. Candle flames are a relatively low energy source. So you can look at low and high melting point. And what you're going to start to see is that with those 4 tests, some groups start to appear. All the things that had this also did this. All the things that are this are also this. So you're going to get 2 groups only. Not 4 groups, not 8 groups, 2 groups. Could there be outliers? Sure. Could there be things that don't, which of these things is not like the other in one of those categories? Yes. But overall, you should be able to reduce those into 2 groups. Now, for each of those groups, for group 1 and group 2, list their properties. So I might say, well, group 1 are all my things with low melting points. They also are blank, and they also do blank. So group 1, group 2, and then you're going to list the properties of those groups. I'm going to leave it at that. I'm not going to discuss the last 2 questions, the general conclusions, so I'll leave you to do those first 2. We will talk more about this tomorrow as we come back to some of these concepts in the notes. And you've got the concrete part that you've seen now. We'll talk about the abstractions of that tomorrow. Okay.